Hello friends, welcome back to our YouTube channel. If you like this video, please like, share and subscribe. I'll share our videos commanded by our experts, so let's begin.
Showcase. If you like, please like, share and subscribe. So let's begin our today's topic. Let's begin.
The next iteration of Android is about to sever the hardware ecosystem in half. With Android 17, Google is rolling out Gemini Intelligence, a deep, system-wide agentic AI suite integrated directly into the operating system. Historically, Android users could rely on a predictable cycle where new software features eventually reached older premium devices through routine updates. That cycle is breaking. Highly capable premium devices released as recently as 2025 are facing a strict lockout from this specific upgrade path. This table maps out an explicit generational divide. Only devices launching in 2026, specifically the Google Pixel 10 and Samsung Galaxy S26, are fully supported. The ineligible tier reveals an immediate cutoff, including the Pixel 9 and Galaxy Z Fold 7. The lockout extends to the highest tier of the 2025 market. Devices that represented the peak of mobile engineering only months ago now lack the physical specifications to run the new interface. This is a matter of physical compute limits. Gemini Intelligence requires a specific combination of high-density memory and sustained neural throughput that previous silicon cannot deliver. Future-proofing a smartphone no longer hinges on guaranteed software updates. It requires possessing the specific physical silicon necessary to survive a transition to continuous, system-wide AI pipelines. The first major physical bottleneck that kills 2025 hardware compatibility is the baseline for system memory allocation. To run the full Gemini Intelligence interface, a device must have a hard minimum of 12 gigabytes of RAM. Devices limited to an 8 gigabyte memory buffer are strictly excluded from the integrated OS features, immediately disqualifying older mid-range and legacy flagship models. This empty 8 gigabyte RAM block shows why the limit exists. First, a baseline footprint runs the core OS. Next, background and cellular tasks. Then, Gemini's spatial audio and HDR. Finally, loading Nano V3 demands massive memory. They collide, causing a system crash. Traditional memory management solves overflow using swap space, writing excess data to the slower storage drive. But for active AI, that isn't a viable solution. An active agent must read screen context and evaluate inputs in real time. Forcing it to retrieve data from swap memory introduces extreme latency, breaking the fluid automation the system requires. While some 2025 flagships, like the Pixel 9, do cross this 12 gigabyte threshold, memory is only the first filter. Expanding the architecture to 12 gigabytes provides the clearance necessary to safely house the model weights and active context windows concurrently with the operating system. For devices with only 8 gigabytes of RAM, there is no path forward. They physically lack the transistor space to hold active agent context alongside a modern OS. Even for devices with 12 gigabytes of RAM, like the Pixel 9, a second bottleneck exists within the processor itself. These legacy devices will still retain basic individual prompt APIs. Tasks like generating a single text reply or translating a sentence on command remain functional. However, they cannot bridge the gap between stateless API execution and the stateful agentic automation introduced in Android 17. This logic flow shows why RAM isn't enough. Left, stateless APIs execute discrete tasks in short bursts. Older chips handle easily. Right, agentic automation requires a continuous high-bandwidth data loop. Forcing this continuous loop through a 2025-era NPU, like the Tensor G5, immediately bottlenecks. On-device agent pipelines must constantly evaluate screen context across the entire operating system. They demand sustained processing throughput that older neural engines were not designed to provide. Forcing this continuous pipeline onto a legacy NPU leads to extreme, unsustainable battery drain. This is followed by severe thermal throttling. The processor generates so much heat that the system degrades overall phone performance to unusable levels just to maintain safe temperatures. Only specific top-end system-on-chips, the Google Tensor G5 and Snapdragon 8 Elite variants, possess the architecture to survive this workload. These specific chips utilize neural engines built from the ground up to be fully optimized for Google's Nano V3 model. These optimizations allow the engine to process the continuous data loop efficiently without triggering the device's thermal limits. Legacy hardware fails because its physical silicon was designed to burst process individual commands. It lacks the sustained endurance required to power a continuous, agentic operating system. The combination of strict memory scarcity and NPU throughput limits definitively locks out the 2025 flagships. For device manufacturers attempting to build Android phones moving forward, these hardware constraints establish a demanding new baseline. Google is treating Gemini Intelligence as a strict certification program, using the brand to force manufacturers into adopting much higher hardware standards across the board. To earn certification, manufacturers must prove their devices meet rigorous media standards, including demonstrably low application crash rates and consistent advanced HDR processing. They must also adhere to strict performance maintenance requirements, such as deploying guaranteed regular gaming driver updates. The most aggressive mandate for certification requires ironclad long-term support assurances. Manufacturers must legally guarantee at least 5 major Android OS upgrades and 6 full years of security updates for the certified device. To promise 6 years of stable software performance under an evolving AI ecosystem, a manufacturer has to start with a massive premium hardware buffer today. That required buffer enforces the strict minimum of 12 gigabytes of RAM and an elite-tier system on chip for any device claiming to be future-proof. Mobile architecture is entering a phase of high-density hardware regulation. Purchasing a 2025 premium flagship today means investing in an ecosystem that Google has already physically deprecated. Android 17 marks the end of the trickle-down software update era. The demands of deep agentic pipelines now explicitly dictate the physical hardware you must buy. Pushing continuous, system-wide artificial intelligence through a smartphone motherboard creates an immediate bottleneck, intense computational overload causing severe hardware stress. Google's upcoming Android 17 Gemini Intelligence system introduces continuous processing demands that completely overwhelm the memory and compute limits of current mobile architecture. This dual-pane timeline visualizes the resulting split. Android 17 operates as a strict architectural reset that permanently locks out top-tier 2025 devices. To understand why a 1-year gap creates an impassable barrier, we need to analyze the 5 specific hardware and compliance requirements driving this exact divide. Early adopters of 2025 premium hardware find themselves isolated from the upcoming ecosystem. The baseline definition of a future-proof smartphone has been permanently rewritten. The current standard for on-device operations utilizes Google's Gemini Nano V2. This model relies entirely on isolated, application-layer generative AI. In this diagram illustrating Nano V2, standard prompt APIs ping the neural processing unit intermittently. The user asks a question, the processor handles the burst, and the hardware goes dormant, resting between tasks. Notice the structural shift required by Android 17's Gemini Nano V3. A persistent automation layer blankets the system. The processor block remains permanently active to manage continuous data streams. This deep agentic AI monitors multiple operating system pipelines simultaneously, interpreting data and executing tasks without waiting for a user prompt. The required computational load shifts entirely from short, intermittent bursts of processing to a heavy, continuous, sustained load. Older devices cannot scale down this experience through software optimization. A continuous OS-level agent demands dedicated physical hardware pipelines designed explicitly for persistent execution. Moving from software theory to the physical constraints on the smartphone motherboard reveals the exact points of failure for older devices. Looking at this digital schematic of a smartphone motherboard, the memory module indicates the first absolute floor. The new OS requires a minimum of 12 gigabytes of RAM. 8 gigabyte systems are explicitly excluded. Hosting a persistent agentic model alongside standard OS processes on an 8 gigabyte framework mathematically guarantees fatal memory swapping and immediate systemic crashes. As the highlight shifts to the system on chip, we see the compute threshold. Only the Google Tensor G5, Snapdragon 8 Elite variants, or directly comparable premium chipsets pass Google's compute filter. These specific SoCs possess localized AI pipelines designed explicitly for continuous on-device agent execution without thermal throttling. These specifications are rigid, bare minimum computational thresholds required to maintain basic OS stability under an agentic load. They are physical necessities, not marketing tiers. This flowchart maps the official exclusion criteria for Android 17 against recent hardware, starting with the 2025 generation. The Google Pixel 9 series internal architecture fails to support the Nano V3 system-wide agentic layer, failing the required NPU processing metric. Samsung's Galaxy Z Fold 7 and Z Trifold face identical rejections. They lack the sustained agentic pipeline support necessary for continuous execution. The OnePlus 13 and Xiaomi 15 models also register failure states under these identical deep agentic hardware thresholds. The common denominator across these exclusions is an NPU pipeline design optimized for burst tasks, not continuous background processing. Achieving an ultra-premium price point in 2025 offered zero protection against the 2026 architectural reset. Shifting the flowchart to the fully supported 2026 hardware reveals the exact configurations that meet the Gemini Intelligence baseline. The Samsung Galaxy S26 series qualifies with confirmed 12GB RAM configurations and Nano V3 optimization built into the hardware. The OnePlus 15 range similarly passes on the strength of its heavily upgraded SoC setup. The Google Pixel 10 family serves as the primary flagship vehicle for this update. However, notice the red sub-branch extending below it. The Pixel 10a is explicitly excluded from the supported list. Excluding the 10a proves the rigidity of the hardware floor. Even budget models built within the compliant next-generation family lack the silicon required to cross the agentic threshold. Moving forward, flagship status is defined strictly by these agent-capable hardware metrics, stripping relevance from brand tier or release year. This certification badge demonstrates that raw compute power and RAM remain insufficient on their own. Original equipment manufacturers must pass rigorous peripheral and systemic certification standards. Devices must support strict media standards, specifically high-tier spatial audio and advanced HDR processing. Performance stability standards mandate exceptionally low OS crash rates, alongside regular, verifiable gaming driver updates. Finally, OEMs must structurally guarantee 5 major OS upgrades and 6 years of security updates. Google uses the Gemini Intelligence ecosystem as leverage, forcing manufacturers to absorb massive long-term software support costs in exchange for access. This leaves the 2025 unsupported devices permanently operating under the older Gemini Nano V2 ecosystem. These older units will retain basic individual prompt API functionalities. Users can still manually request isolated generative tasks. They will completely lack access to the system-wide agentic automation layer.
The manual, user-initiated structure of the legacy fallback contrasts heavily against the background, continuous execution of Android 17. While 2025 models remain functional smartphones, they are permanently isolated from the core evolutionary track of the Android operating system. Returning to our initial timeline, the 4 pillars of the new baseline are established: a 12GB RAM floor, a Nano V3 optimized NPU, premium 2026 SoCs, and rigorous OEM support guarantees. This threshold marks the definitive end of software-side backward compatibility for flagship AI features. Mobile developers and analysts must permanently reset their baseline expectations for both application development pipelines and hardware lifecycles. The shift to true on-device agentic automation has forced a hard ecosystem bifurcation. The future of Android begins strictly with the class of 2026.